Okay, we are continuing with the Math 4 final exam review. We're on problem 16. The instructions say simplify, assume that all variables represent positive real numbers, and express the result with positive exponents only. Remember that when they tell us that the variables represent positive real numbers, we don't need to worry about whether or not we need absolute value signs around the answers. So that's what the positive real numbers means. Starting with A, we have the square root of 36, x to the 18th, y to the 38th. Remember, when we're taking a square root, what we're looking for underneath our radical sign is two identical factors or multiples of two identical factors. So 36 is really easy to see. That the square root of 36 is 6. We know that. When we get to the variables, what we need in our exponents is even numbers that are multiples of 2, because remember, a square root is like this is a 2 right here. So we're looking for sets of 2 that divide into x to the 18th. So the easiest way to find that out is say 18 divided by 2 is 9, and 38 divided by 2 is 19. So the answer to that would be 6, x to the 9th, y to the 19th. Okay, when we come to B, we have z squared y raised to the 1/4 power over z to the negative 1/2 y to the positive 1/2. So the first thing I'm going to do is get rid of my parentheses in the numerator by taking that to the 1/4 power. So remember, the rule is when you're taking a power of a power, we multiply the exponent. So for z, I have squared times 1/4 power. 2 times 1/4 is 2/4, or I can reduce that to 1/2. And y is raised to the first power, so y to the first power raised to the 1/4 power is just, of course, y to the 1/4 power. In my denominator, I don't have a new power to raise it to, so I have z to the negative 1/2 and y to the positive 1/2. Okay, we know that when we're trying to get rid of a negative exponent, we can move it across the fraction bar to make it positive. So that's what I'm going to do here. I'm going to move this up to the numerator, and now I have z to the positive 1/2. For the z that was previously to the negative 1/2, I have z to the positive 1/2, which I already had there, and I have y to the 1/4. In my denominator, I still have y to the 1/2. Well, I know I'm going to have to do something with the y's in the numerator and denominator, so I would rather they have the same denominator. So I'm going to make this y to the 2/4. So these now have the same denominator. Okay, back to the numerator. I have z to the 1/2 times z to the 1/2. Remember, the rule for like basis is to add the power, so I'm adding 1/2 plus 1/2, which is 1, and that just gives me z. And now, with y to the 1/4 in the numerator and y to the 2/4 in the denominator, I can use my quotient rule, which says subtract your exponents. But remember, I like to say take the bigger exponent and subtract the little exponent. 2/4 minus 1/4 is 1/4, and then the answer goes where the bigger exponent was. So that's y to the 1/4 in the denominator. I could have, remember, said take the power of the numerator minus the power of the denominator. That would have been 1/4 minus 2/4 is negative 1/4. Put y to the negative 1/4 in the numerator, and then because it was negative, moved it down to the denominator. And remember, that's why I like to say take the big one, subtract the little one, put it where the big one was, because that saves you a step. And that's your final answer, z over y to the 1/4. Okay, when it comes to c, the first thing I'm going to do is take my powers of my powers, which means multiply this power times the power outside the parentheses. So that's going to give me initially x to the 3/6, which I'm going to reduce to 1/2. And we'll see later if I'm sorry. I should have left them at 6's. Then y to the 4/6 becomes y to the 2/3. I may still at the end need to go back and make things have the same denominator. We'll see. Okay, y to the negative 7 times negative 1/3. I said y, I meant x. That's x to the positive 7/3. So that's not going to need to cross the equal sign. And then y to the negative times negative 1/3 is y to the positive 2/3. Let's start with the y since they both have the same power. What is any number over itself equal to? Hopefully you remember that's 1. So y to the 1, I said that wrong, didn't I? Y to the 2/3 over y to the 2/3 is 1. Not y to the 1, but 1. So those divide each other out. So now all I have left is x to the 1/2, x to the 7/3, and oops, looks like I wanted to leave that in 6 because I want them to have the same denominator, so I'm going to change them back to a denominator of 6 since 2 and 3 both go into 6. So 1/2 is 3/6, and 7/3, I'm going to multiply the denominator by 2, so I multiply the numerator by 2. That gives me x to the 14 over 3. And now if you use the same rule that I used over here, whoops, I said 3 and I meant to say 6, didn't I? I multiplied both my numerator and my denominator there by 2. So that 7 times 2 was 14 and 3 times 2 was 6. Okay, I'm going to use my rule, take the big one and subtract the little one. 14 over 6 minus 3 over 6 is 11 over 6. The bigger one of those was in the denominator, so that's going to be x to the 11 over 6, and it has to be in the denominator. Well, if I don't have anything in the numerator, what do I put there? And that's a 1. Always have to have a placeholder, and let me rewrite that so you can see it better. It's 1 over x to the 11 over 6. That's my exponent. Let's make that x a little bigger so you can really see it's an exponent. There we go.